Okay, more practice for balancing redox reactions. This one's a little bit different because in this example, we're going to have the same element getting reduced and oxidized at the same time. So here we have silver nitrate and sodium hypochlorite going to silver chloride and silver chlorate and sodium nitrate. Again, just like in the last example, we're looking at these nitrates and we're recognizing since they appear as nitrate on both sides of the equation, that nitrogen isn't going to change its oxidation state. Similar, we're looking at the silvers, and if I look at the silvers carefully, I'm going to realize that the silver is not changing its oxidation state at all times. It's going to be +1. It only has one valence as a metal, so chances are it's going to have to stick with that one valence. It's not for sure, but it's pretty likely. So that's a +1, that's a -1 for the nitrate. Here, silver is +1 with its -1 for chlorine. And here it's going to be +1, and this chlorine is going to have a funny oxidation state. So 3 times -2 gets me -6, and so the chlorine here is going to be +5. And then sodium +1 with the nitrate -1. Now here, sodium is a +1, oxygen is a -2, so this chlorine is going to be +1 in this specific case. So what's interesting here is that chlorine is going to -1, and the same chlorine is going to +5. So the same element is getting oxidized and reduced in the same reaction. Cl +1 is going to Cl -1, so there's your reduction, and Cl +1 is going to Cl +5. A little strange, but don't get bent out of shape. I'll show you what we do with this. Doesn't really matter from a half reaction standpoint that it's the same element. We're just going to do the same thing and write out our electron change. Here, +1 to +5, so it must have emitted 5 electrons. Here, +1 to -1, so it must have gained 2 electrons. And what that means then is I'm going to multiply this guy by 2 to make my 2 electrons match my 4 electrons. So 2 times 2 is 4 electrons, 2 Cl plus, 2 Cl minus. Now, this Cl minus is associated with this Cl minus, so I can put this 2 right here. And this Cl plus 5 is associated with this Cl plus 5, so I can put my 1 right there. But what should I do about my chlorine on this side? Well, the way to think about this is that that chlorine must feed this reaction and this reaction. So it's providing 2 to this reaction and 1 to this reaction, so it must provide 3 chlorines to provide both of the balanced half reactions. So I can simply total my coefficients to recognize the total amount of chlorine that must be supplied. Okay, so now we've dealt with the fact that we have the same element being oxidized and reduced. We can just now go and balance the additional species and finish this equation. And apart from the fact that we had that one funny thing going on, this is not a particularly hard one to do. I'm just going to do my usual erasing all the other stuff so I can focus on my balancing now. Okay. So now, the thing I'm going to balance next are the silvers. I have 3 silvers on this side, Ag. I have 3 of them on this side, so I'm going to need 3 silvers on this side to balance them out. Okay, that's silver. Now I'm going to work with the nitrates. I have 9 nitrates on this side, so I'm going to need 9 nitrates on that side. No, that's not right. Sorry, I'm multiplying into that 3, but that's NO3 to the 1. So I have 3 nitrates on this side, so I'm going to need 3 nitrates on that side. Oops, I nearly screwed that up. And that's going to get me 3 nitrates. And now, my last element, which is going to serve as my check for this one, which is relatively straightforward, is I have 3 sodiums on this side and 3 sodiums on that side, and those two are going to be equal, so hooray, I'm done. So again, it doesn't happen very often. You're not going to find a ton of examples like this, but sometimes the same element can act as both get oxidized and get reduced, and that isn't such a huge thing. All you need to do is make sure you take the element as the reactant and make sure it has enough to feed both the half reactions that it's involved in.